When you invented the blue LED back in 1993, did you imagine the sort of revolution that you were going to create in the lighting industry?
When I invented blue LED in 93, there are still no high efficient green LEDs. So next target was green LEDs. So in 96, we could develop the green LEDs. And since 96, after developing green LED, we expect a huge market for revolutionize all of the lighting, all kind of lighting. We expect we can replace all conventional lighting with LEDs at that time.
And knowing what you know now in terms of the adoption and the changes that have ensued, is there anything that you would have done differently had you had known that?
I think I expected some, but this is right now, when I attend the lighting show, all of lighting is now LED lighting. At that time, I never expected this huge change, dramatically. Did
the revolution and the changes that followed, did it happen as you were expected it to happen?
Yeah, but I expected that I can change replace all conventional lighting, but I couldn't imagine the market size at that time.
Has it been more rapid than you expected?
Yeah, I think so, because usually these devices, we have to improve the lifetime, but using gallium nitride, you didn't care about the lifetime. Initial stage lifetime is okay, so very fast, everything very fast.
You've done an awful lot of work recently in terms of gallium nitride and gallium nitride technology. Can you explain to us a little bit about the benefits of that?
Yes, because right now the biggest issue of the LED lighting is price, cost. So using GaN, we can reduce the cost dramatically, because when we talk about the LED, the cost of the lighting, we have to always refer to dollar per lumen. But using GaN, we can increase the current density 10 times or 20 times higher than that of conventional LED on sapphire or silicon carbide. So it means that lumen become 10 times or 20 times higher. So it means the dollar per lumen become 1/10 or 1/20. So we can reduce dollar per lumen dramatically. It means we can reduce the cost dramatically using GaN on GaN. So that's, I think, GaN on GaN should be the next generation LED.
So what do you expect to see in terms of color rendering and efficiency in the coming years?
I think using GaN on GaN, we can increase the reduce the cost. Also, we can increase the current density. Using a point license, we can increase the lumen dramatically. So in that case, we can use violet LED instead of blue. And using violet LED, we can improve the color rendering index dramatically. Usually using blue, currently available white LED is blue excited phosphor. In that case, color rendering index is around 80. But using GaN, also using violet plus phosphor technology, we can increase the current rendering is more than 95. So using GaN, we can also improve the CRI dramatically. And so I think GaN is next generation technology, no doubt. We can achieve the more than 100 lumen per watt very soon using GaN technology. Also CRI is very high, with a very high CRI.
And beyond 100 lumens per watt?
I think with a high CRI and color temperature around 2,700, 200, I think in that case, CRI is around target is 150 lumen per watt.
And at warm color temperatures?
Yeah, CRI is more than 95 and the R9 is more than 90 something. Yeah.
And you could see that in the next 2 to 3 years?
I think it takes a couple of years. Yeah.
In terms of GaN and GaN technology, how will that be commercialized?
I think company named Solar is already starting mass production. I think very soon, mass production capacity is increasing, and you can easily buy any place. I think. So, yeah, very soon.
Do you guys have plans to broaden the technology by licensing it to other manufacturers?
I think so. I'm not the CEO of the company. I'm just a co-founder, so I can't make a decision. So. It's difficult for me to comment on it. Yeah.
What's your view of OLED?
OLED is still, for lighting application, it takes a long time. Already, I have talked to many OLED people, also the inventor of the OLED. And this is due to the reliability problem for lighting application, because they have to make a very bright by increasing the current density, same thing, With increased current density, the reliability becomes very poor. So I think lighting application they say it will take a long time.
You don't sound enthusiastic about OLEDs in the mainstream commercial market.
The problem is reliability of blue OLED. Blue color is very reliability very poor because blue means organic material is very weak against the irradiation of the blue or violet. I think it will take time because also lighting application we have to increase the current density to make a bright one. So in that case, I think reliability is the biggest issue for OLED. For display, it's okay. Display is not high. They don't require the high efficiency. Also, decoration light, they don't. So OLED is okay. But for the lighting application, I think it will take a long time.
Shuji Nakamura, thank you for talking to Lux Review.
Okay, thank you.